Hi, Professor. So, this is my research project for the pyCaret to predict the hourly bike rental demand. So, I've used the bike sharing dataset, the R.csv file, and the pyCaret regression tutorial. I followed the Google Colab file that you gave. So, so this was just to check if I'm using the correct Python version because it didn't work with Python version if it was above 3.12, so I had to downgrade to Python 3.11. So we're importing the libraries, um, uh, then r.csv, which I added to the project folder. Tf.head is just to print the first 5 rows of the CSV file. Then the second one, as per the assignment requirement, we had to drop the columns, casual and registered, so I have dropped them, and this is again printing the first 5 rows. Then setup of the pyCaret regression environment. So we import the pyCaret regression module and we call it setup. So this basically, I guess, pre-processes all the data and then normalizes it as well. So in this we just tell pyCaret like on what we are targeting. According to assignment, I had to target the CNT column, so pyCaret knows which to work with, and this is what it gave me. Then it compares all the regression model. This is the command for that to compare all the models with just one line. pyCaret tests all the multiple regression models, and then it gives the best model. For my case, it's the extra trees regressor, and these are the values. For performance metrics, I used RMSE and R square, and on the basis of that, I have uh, you know uh, like figured out which is the best model. After that, training a linear regression model. So basic linear regression model using the create model and LR. This is basically for comparison, and as expected, the values were very far off because linear model is not going to work with a data set like this. Then I use random forest similarly with RF, and this performed way better. The R of the day is the biggest one. Um, yeah, so this model performed much better than linear regression. Sorry. So yeah, and then tuning the best model, it tunes the best model and then fits 10 folds for all the 10 candidates. The performance after tuning was worse. R square and RMSE, the two parameters that we use for performative metrics, actually dropped down. So pyCaret automatically uh, uses the old model for further uh, tuning. It doesn't use the hyper parameter tuning model that because the values were way off. Then we just finalize the model, predict it using the final model, and then just save the model and its pipeline so that we can use it just by loading it, and then we can use it to predict with new data sets. So right now this just used the r.csv dataset, which was used for training and testing purposes. So that's why the prediction is 100% correct with r square value of 1, because it just predicted the same dataset that it used for train test. That's why it's like perfect. When we use new dataset, then it will give different values. But of course, the extra trees regressor will be by far the best model that has to be used. This is the conclusion. And then these are the predicting plots, all of them. The final model, residual, this for the error one, this for the feature or learning curve, and then the setup with the normalize equals to true. Then taking the top three models and then comparing them, and again extra tree regressor performs the best, and then tuning the top three models and then doing it again, and again, after tuning the original model, had better values than the tuned model. It was way far off, so it will just use the original model again. Then this is the blend, this is the stack, this is the leadership. So this is basically it. It basically ranks all the models based on their R square and RMSE values. This is auto ML, and then we just finalize the model using the tuned best, and extra trees regressor again um, comes at the top. So this is just the conclusion that I have added, um, basically explaining whatever I did for this project. And then this is the GitHub repository with abstract, and then all the overview, and I have also uploaded the YNB file here, so it has everything in it. And then with this, this is the Google form as well. This is done as well. um, I I went through these three literature review, which also used this data set and worked with it, and my data and my conclusion comes very similar to all three of these, which is the extra trees regressor is the better one compared to every other, and the R square and RMSE values are similar as well. And that's about it for this project. It was a good project, um, because since we were using like real-time data set, and we were comparing different models, so it made me it helped me to understand the different models and how they work, which models are good for classification, which model are good for regression, and then all the graphs also help in understanding the data better. So overall, it was a good project for me. I had a nice time working on it, and yeah, that's about it. Thank you if you watched till here, and have a nice day. Bye.